Hi guys, so today we're going to begin Unit 3, which is on parallel lines and perpendicular lines. Today we will talk about parallel lines and their transversals. So let's just kind of go over some basic vocabulary. Parallel lines are when you have two lines that never intersect. They have the same exact slope and they have different y-intercepts. So here's an example of how it looks. So you have two lines that look like they will never intersect. One way that you know for sure that they're parallel lines is that those two arrows indicate that they are parallel. So the next thing that we're going to talk about are skew lines. Skew lines are not in the same plane, and they are not parallel, and they do not intersect. So here's an example of some skew lines. So if you look at the two lines that I drew, those two lines are not in the same plane, and they are not parallel, and they will never intersect. So that's kind of an example of some skew lines. For parallel planes are planes that never intersect. So here's an example of what that might look like. So if you look at the top and the bottom of this rectangular prism, they will never intersect, and they are planes. So let's look at example 1. Example 1 says use the figure below to answer the questions that follow. It says what lines are parallel to AB? Well, you can see here that EF is parallel to AB, and so is CD or DC. So EF and DC are both going to be parallel to AB. They will never touch, and they have the same slope. And then B says, what are other sets of parallel lines? So there are several here. I'm going to give some examples. So I see that DA is parallel to CB. I see that FB is parallel to EA. And I see that ED is parallel to FC. Next, it asks us to find a pair of skew lines. Remember, skew lines are when they're not parallel, and they don't intersect, and they're not in the same plane. So one example of that would be DA and EF. So if you look, here's DA, and then here's EF. Those are not in the same plane, and they are not parallel, and they will not intersect. Next, it says name a pair of parallel planes. I only see one set of parallel planes, and those are EDA and FCB. So those are my two planes there that would be considered parallel. Alright, so the next two things that we're going to talk about are some postulates. So the first postulate we'll talk about is the parallel postulate. So this postulate states that if there is a line and a point not in the line, then there is exactly one line through that point that's parallel to the given line. In other words, if we have this diagram here, there's exactly one line through P that's parallel to L. I know that this is a little bit confusing when you first read it, but it's actually not that hard to understand. So in other words, if you have a line here and a point here, there's only one line that can go through that point to make it parallel to that other line. So obviously it wouldn't be this line. It wouldn't be this line. There would only be one line to make that point, to make it parallel. So it would have to be the line with the same slope. The perpendicular postulate is basically the same thing, except we're talking about perpendicular lines. So if there is a line and a point not in the line, then there's exactly one line through that point that's perpendicular to the given line. So there's exactly one line through P that's perpendicular to L. So in other words, if you have a line, we call that L, and we have a point P, there's only one line that we can draw through that point P that's going to be perpendicular to L. So it would look like that. Okay, so the next thing we'll talk about is transversal. So a transversal is a line that intersects two or more lines in a plane at different points. So if you have two lines, it doesn't matter how those lines look. A transversal is going to be a line that cuts through those two lines. So this right here would be considered the transversal. Now, when two lines are cut by a transversal, we have different types of angle pairs that are formed. We have alternate interior angles, we have alternate exterior angles, same side, or sometimes called consecutive interior angles, or same side consecutive exterior angles, and we also have corresponding angles. Now, before we begin talking about each of these different types of angle pairs, I want to go over the interior part of a transversal and then the exterior part, the interior part of two lines versus the exterior part. So in this example here that's shown, this diagram that's shown, we have line X and line Y, and then we have line Z as the transversal that cuts through those lines. Now, if you look at this diagram, the points between, or the entire area between lines X and Y, that would be all considered interior. Anything on the outside here and here would be considered exterior. So that'll kind of help you a little bit when you're trying to decide whether something's exterior or interior. Okay, so alternate interior angles are two non-adjacent interior angles on opposite sides of the transversal. So they're alternate because they're opposite sides, and then they're interior because it's inside, between or inside of the two lines. So in other words, 6 and 3 are alternates of one another. They're on opposite sides of the transversals, and then they're both interior. That's why it's considered alternate interior angles. Now, another pair of alternate interior angles would be 2 and 7, because once again, they're on opposite sides of the transversal, and they're inside. They're on the interior part of the two lines. So once again, we have my two examples would be angles 3 and 6. Those are alternate interior angles, and then so are 2 and 7. The next thing we'll talk about is alternate exterior angles. So two non-adjacent exterior angles on opposite sides of the transversal. Alternate means opposite, right? So they're going to be two angles on the opposite side of the transversal. And then it also says that it's exterior, so then it's going to be on the exterior side. So if I look at angle 5, the alternate exterior angle to that would be angle 4. They're on opposite sides on the exterior. So then those would be considered alternate exterior angles. Another pair would be 1 and 8. Those are also considered alternate exterior because they're on the outside or the exterior part of the lines, and then they're alternates because they're opposite sides of the transversal. The next thing we're going to talk about is same side or consecutive. Same side and consecutive mean the same thing, and sometimes I'll use either of those two. So either same side or consecutive interior angles. So we know that we're talking about the interior portion, and we're also talking about the same side or the consecutive side, which means it's going to be on the same side of the transversal. So if we look at that, 2 and 3 are considered same side or consecutive interior angles because they're on the same side of the transversal and they're inside. And another pair would be 6 and 7. Those are on the same side on the interior. Same side or consecutive exterior angles are, you probably guessed it, on the outside of the two lines and are on the same side of the transversal. So an example of that would be 5 and 8, or another example would be 1 and 4. For corresponding angles, those are two angles in similar positions relative to the lines and the transversals. So basically, if you have something on the top left of one line, then the corresponding angle to that would also be on the top left of the other line. So then 1 and 3 would be considered corresponding. Another example would be 2 and 4. Those are in the same position on the two lines. Another example would be 5 and 7. Those are in the same positions. And then the last example would be 6 and 8. So they're both on the bottom right. So those are written out. Let's move on to example 2. All right, so for example 2, it says, use the figure below to classify the angle pair and determine the transversal that forms them. So what you're going to do is you're going to find, they're going to give you an angle pair. You're going to tell us what the transversal that goes through that is, and then the type of angles those are. So I want you to pause this video and try this yourself. All right, so to check your work, if we look at examples 1 and 5, we can see that those are corresponding whenever line C is the transversal. If we look at 4 and 6, that's these two here, we can tell that those are alternate interior angles with the transversal being line C. If we look at 4 and 10, those are also considered those are actually alternate exterior angles when the transversal is line A. If we look at 2 and 9, those are consecutive interior angles whenever the transversal is line A. If we look at 4 and 12, those are considered corresponding angles when the transversal is line A. 3 and 9 are alternate interior angles when the transversal is line A. 2 and 7 are alternate exterior angles when the transversal is line C. 3 and 12 are considered same side or consecutive interior angles whenever the transversal is line A. And 1 and 7 are consecutive exterior angles or same side exterior angles when the transversal is line C.